In today's class, I'm going to explain finding the missing part of a percent. Okay. Here, a question from the real life situations. A battery that lasts for 12 hours has been used for 7 hours. What percent of the battery life has been used up? So, let me describe a situation that I charged my phone. I know that once if I charge my phone, then it comes for 12 hours. Okay. And I'm traveling along with my daughter. My daughter was on the phone and she was playing the video game. Then, after some time, I realized that the battery was down. So, 7 hours of battery life is already used up. Then, I know that my office people they keep calling me over phone. In case if there's no charge, then I'll be in trouble. So the question is if I take a scenario that suppose uh, if there is even if you take your iPhone or Samsung etc., then it shows the percentage like 30% battery is left, 40% is left, and so on. So, if I see that about 30% or 40% of battery is left, I may ask my daughter to stop playing because if she is continuously playing means if the battery is used up, what happens is I can't receive calls from my office and I'll be in trouble. Another scenario is, let's say that a pilot is flying the flight and he noticed that the fuel is only 10% left and he has to go a long way. So in such case, then he may bring it down to the nearest airport for refueling the tank. So before going to the actual topic, if you want to find the percentage, very simple thing is here I see that it's a part of the total and 12 hours is the total, right? Again, I'm repeating 7 hours is a part of the total 7 hours. That's the life. And the total life of the battery is 12 hours. Therefore, if you want to express this one as a percentage means simple is numerator is part and denominator is total and times 100. That gives you the percentage. So, I know that out of 12 hours, 7 hours is a part. Let me take that 7 in the numerator and total is 12 hours, that is in the denominator, times 100. 7 over 12 is a fraction, but 100 is not a fraction. In order to avoid a lot of confusion, take the denominator as 1 and make the second value also as a fraction. That eliminates a lot of confusion. This sum can be solved in two ways. One is 7 times 100, which is numerator times numerator and denominator times denominator. So when you do that, you will get 700 divided by 12. I see that both are really large numbers. Instead of that, you think of canceling. Cancellation means I hope you remember that in butterfly method, 100 is the numerator and 12 is the denominator. Now, think of a number with which you can divide 100 and 12 both. I know that both are divisible by 2, even 4 also. Let's not talk about the large numbers. So, I know that 100 and 12 both are divisible by 2. So, 2 times 6, 12. 2 times 50, that is 100. Now, can I divide 50 and 6 once again by any number? Think of a number with which you can divide both 50 and 6. Here, I see that 50 is divisible by 2. So, 2 times 25 gives me 50. 2 times 3, that gives me 6. Now, can you divide 3 and 25 by any number? Means it is no. Now, let's multiply the values in the denominator, which is 3 times 1. 3 times 1, that gives me the denominator is 3. And 7 times 25, you know quarters. Quarters, if I take 7 quarters, 4 quarters make $1, and 3 quarters, that makes 75 cents. Therefore, $1.75, which means 175. I think this is a better option as compared to 700 is divisible by 12. I know that these numbers are really large numbers. Instead, if I take 175 divide by 3, this is easy to compute. Now, let me think of 3 table. 3 5s 15, 3 times 6 is 18. I know that 18 is larger than 17, so I cannot take 3 times 6, then I can take only 3 times 5, that gives me 15. Let me take away 15 from 17, then I'm left with 25. Now 3 times, let me read 3 table. 3 5s 15, 3 6 18, 3 7s 21, 3 8s 24, 3 times 9, it is 27. I know it's that 8 o'clock. 27 is larger. Therefore, let me take 3 times 8. 3 times 8, that gives me 24. I'm left with 1. If you want, you can express this one as a decimal or as a fraction. If I take, you know that if I include a 0 here, then I have to introduce point there. So 3 times 3, that gives me 9. Then just I'm stopping here. So this is equal to 58.3% of batteries used up. So already 58.3% of battery used up means, it is almost close to 60%. So 60% of battery is used up. As I mentioned before, I'm traveling and I need my batteries to be used up. Otherwise, if my battery is my phone is switched off, then I can't receive phone calls, any emergency calls from my office. Okay. So this is how we compute the percentage. Now let me go to the next question. Let me read the question. Use this table that tells how many pies a bakery makes each day. Pies made daily: apple pies 80, cherry pies 50, peach pies 40, blueberry 30 pies, banana cream pies 25, key lime 15. So total pies made daily is 240. Always read the instructions, read the question, and identify the important information. So here, I know that this is the total number of pies. Now, what percent of pies are apple? So you have to remember the golden rule, that simple, that is part over total times 100. Now, we are talking about the apple pies, therefore, apple pies are here, and the next question is blueberry. So here blueberry means I see that blueberry pies are here. Right? Now think for a moment and how to solve this. Make a plan in your mind. Make a plan in your mind. Awesome job by both of you. That's really great. I see that 2000 over 60, this is correct, and 300 over 24, this is also correct. So when you are computing, there are high chances of being struck this way. Earlier I told that if the last digit is 0 in the numerator and denominator, then you can cancel them. Agreed? In fact, if you observe carefully, if you take 80 over 60, not only the butterfly method, you can check the numerator and denominator, and if you find any zeros, then and there you can cancel. Okay? Now, what is 8 times 25? That gives you 200 over 6. So 200 over 6 means, again, I see that I can divide both these values. 2 times 1, that is 2, 2 times 3. Therefore, I am left with 100 over 3. I'm pretty sure that 100 divided by 3 means that this can be computed easily. Okay? In the second calculation also, I see that 30 and 24, not only butterfly method, you can look at the numerator and denominator. Can you divide the numerator and denominator by any number? It need not be 2 always, it can be something else also. In fact, you can divide both by 2. I hope you remember the test of divisibility technique. In test of divisibility, you take if the last digit is 0 and 4, I see that these both are divisible by 2. Therefore, 30 divided by 2 and 24 divided by 2. You will get 15 here, 2 times 12. Now, can you divide 15 and 12 by any number? As I mentioned before, it is not necessary always 2. Can you divide by 2 15 and 12? No. Can you divide by 3? Yes. So 15, yes. 15 divided by 3, that is 3 fives. And 12 divided by 3, 3 fours 12. Therefore, 5 over 4. So, if you have large numbers, it is really difficult to do any calculation. So, instead of that, if I cancel out and if I take 5 over 4 times 10, this is further easy. Again, let me think of these two values. Oops, my bad. So, let me move the screen a little up. So here 4 and 10. I know that these two are divisible by 2. So 2 times 2 and 2 times 5. So 5 times 5, that is 25 over 2. And this is very easy to compute. And the other side here 100 over 3, the 100 over 3, this is also easy to compute. Whereas if you are taking the large numbers like say 2000 divided by 60, oh my gosh, these are really large numbers, and dividing by 60 table, it leads a lot of confusion too. Okay, right. Then now think of dividing these values, which is 100 over 3, and what will be the answer, and 25 over 2, what will be the answer. Think for a while and compute on your own. See, when you divide 100 by 3, you should get 33 point. You should get 33.3333. 3, 3, it goes on. So here, the digit which is repeating, I see that 3 is repeating. Okay, so this is called as a recurring decimal. This is called as recurring decimal. So instead of writing these many times, we keep this decimal point and we put a bar. This indicates that 3 repeats. Okay, well, then oops, it is 2000. Okay, right. So let's go to the next page. So this is the main topic for the day, is find the missing number. Here, what percent of 50 gives you 45.5? So, what percent of 50 gives you 45.5? Here, I would like to introduce a little bit of algebra. As I mentioned in the previous sessions, the missing number in math, we consider it as a variable. Most of the time, we take it as x. So, x percent of 50 equals to 45.5 I'm taking. You know that percent symbol means, per cent, which means out of 100. So let me write this as a fraction. Out of 100 means that goes to denominator. Don't forget, half means it is times 50 equals to 45.5. I don't like to deal with the decimals. I try to avoid. I see that after decimal there is a single digit, therefore in the denominator I'm taking 10. To solve the variables, we have to isolate the variable. We have to isolate the variable. So, in the previous sessions already explained, we go by inverse operation. If any, I see that here 50 is multiplying. The inverse operation of multiplication is division. So, if I divide by the same value, not only one side, please remember, when you do an operation on the left hand side of the equal to side, you have to do the same thing on the right hand side too. So what is 50 divided by 50 means? You know that 50 times 1, that gives you 50. Therefore, you are left with 1. Now, on the left hand side of the equal to side, x times 1, which is 1x over 100, equals to 455. Denominators, there are two denominators, so 10 and 50, you may write this way. We'll compute this one later. Next, as I mentioned before, we have to isolate the variable. Therefore, for isolating this x, you have to eliminate this 100. I see that 100 is in the denominator. Denominator means x is divided by 100. X is divided by 100. Does it make sense? Yes. X is divided by 100. So what is the inverse operation of division? What is the inverse operation of division means? That is times. So let me take times the same value, whatever the denominator it may be. So if it is 10, you multiply by 10. If it is 100, multiply by 100. So you take the same value. By the same time, please don't forget to take the same operation, which is times 100 on both the sides. Therefore, here I am taking times 100. In butterfly method, 100 divided by 100. 100 divided by 100 means 100 times 1, that gives me 100. Therefore, these two are cancelled. Now you are left x equals to 455 times 100, denominator is 10 and 50. Oh my gosh, two large numbers. But nothing to worry about these numbers. They may seem to be very large numbers, but you know that especially if the last digits are zeros, that's very easy to compute. So 0 and 0, I can cancel them out. Now 10 divided by 5. I know 5 table, 5 times 1 and 5 times 2. Okay. Next, again, you may think of a butterfly method. So here I see that 2 times 1 is 2, 2 times 5, it is 10. So I am left finally with 455 divided by 5. I don't want to mess it up, so let me. That's the reason always I suggest you to make a column on the right hand side. Make a column on the right hand side. Let's say that so that will not disturb the mainstream. Whenever you are solving problems, draw this one. We call it as this is meant for doing your calculations. So let me take this 455 divided by 5 to this side, and let me read 5 table. 5 times 9, which is 45. 5 times 1 is 5. Therefore, I got 91. Therefore, the value of x is 91. So what does it mean? What does it mean x equals to 91 means? X equals to 91 means what percentage means 91% of 50 equals to 45.5. So 91% of 50 equals to 45.5. That's the answer. Let me take one more question. Oops. Let me take one more. This time, percentage is given, but the number is missing. 59% of what number equals to 23.6? As I mentioned in my previous example, 59% means out of 100. Half means times. What number? I don't know what is the value of this, therefore let me imagine a variable. Just now I explained that the unknown value, usually we take it as English alphabet as x, equals to 23.6. I know that the decimal calculations are slightly hard, so instead of taking 23.6, 236 over, after decimal, I see that one digit here, one digit. Therefore, let me take 10. This contains 10. So after decimal, one digit. Therefore, you take 10. I mean to say that 10 that contains 10. Okay. Now we have to isolate, just like the previous one. If you want to find the value of the variable, you have to isolate the variable and you have to eliminate these numbers one after the other. Let me start with this one, that is the denominator part. That's the denominator part. Denominator, which means divided by a division. I repeat, let's say that 10 over 2, which means 10 divided by 2. You know that if there is denominator, therefore that shows that 10 is divided by 2. right? So here I see that 59 over 100 means 59 over 100 means 100 is dividing. So what is the inverse operation of division means? That is multiplication or times. So times 100. Don't forget, whatever you are doing on the left hand side, the same thing you have to, oops, I'm sorry, the same thing you have to do on the right hand side. So I see that here times 100. Therefore, on both the sides, I have to take times 100. We will compute later. So 100 divided by 100 by butterfly method, that one 100 ones are 100. So I'm left with 59 times x equals to 236 over 10 times 100. As I mentioned before, the variable is to be isolated. So we have to get rid of this one. How to cancel out means I see that 59 is multiplying with x. The inverse operation of multiplication is division. So let me take division. Don't forget, when you are dividing on one side, the other side also you have to go for division. So if I divide on one side, the other side also I have to divide. Don't forget this point. Now 59 divided by 59. So 59 ones are 59. So I'm left with x equals to 236 over 10 times 100 over 59. As you know that we prefer the butterfly method again and again. And so it is 100 divided by 10. Okay. So 10 times 1, that gives me 10. 10 times 10, 100. Now, can I divide 10 and 59? I mean to say that is there any number that can divide 10 and 59? It seems no. There is a small trick. There is a small trick. Most of the time, the questions are designed in such a way that though these numbers seems to be very large numbers, if I were you, my thought process goes this way. 5, this is the first digit, and the first one or two digits you take 23. So approximately how many times I can divide 23 by 5? Approximately. I'm not saying exactly. I know that I cannot divide 23 by 5 exactly. But approximately means 5 ones are 5, 5 2's 10, 5 3's 15, 5 times 4, that is 20, 5 times 5, that is more. 5 times 4, that gives me 20 approximately. So instead of 5, you take 59. I repeat this, I am taking 59. And we thought that times 4, 5 times 4 gives me 20. So let me try 59 times 4. Most of the time, the questions are designed in such a way that you'll be able to divide. So let's see what is 59 times 4. 4 times 9, that gives me 36. 4 times 5, 20. Add 3, 236. Hey, I got it. Therefore, 59 ones are and 59 fours, that is 236. Therefore, the value of x is, let me multiply 4 times 10, that gives me 40, and denominator is 1 time 1. 1 time 1 means just 1 only. Therefore, the value of x is 40. So what does it mean? Which means here 59% of What number means 59% of 40 equals to 23.6. If you want, you can compute this separately. What is 59% of 40? Then you will see that you'll end up with 23.6. Any questions on this?